Welcome back to the best news show on YouTube. Before we start, I have a little message from Professor Akim Zales at the University of Innsbruck. In this episode, we got loads of news to cover, including the Boolean Pythagorean Triple Problem, Thomson's problem, and why women are leaving STEM subjects. Welcome to Maths News. The first news today is about a problem in the field of Ramsey theory called Boolean Pythagorean Triple Problem. Pythagorean triples are a set of three numbers which can be put in the form of a squared plus b squared equals c squared, like 3, 4 and 5, because 3 squared plus 4 squared is 5 squared. Now the Boolean Pythagorean Triple Problem asks whether it's possible to divide natural numbers into two groups so that neither of the groups contains any Pythagorean triples. Or in other words, can you divide natural numbers so that numbers like 3, 4 and 5 don't go in the same group, or 5, 12 and 13 aren't in the same group, and you get the idea. Back in the 1980s, there is a $100 prize up for grabs if anyone can solve this problem. Now, three mathematicians, Martin Whaley from the University of Texas, Oliver Kuhlman from the University of Swansea, and Victor Marek from the University of Kentucky, came up with a solution for this very problem. Their solution, their proof, showed that this was possible for numbers up to 7,824. You can divide natural numbers up to 7,824 into two groups so that neither of them contain Pythagorean triples. Any numbers beyond that, and you can't do it anymore. The proof by these three mathematicians involved a method called the cube and conquer method, and involved checking all the different combinations of groups they could put the numbers into. And how many groups were there they had to check? Well, they had to check that the natural numbers from 1 to 7,825 cannot be split into two groups. So they had to check all the different combinations of splitting up the groups from natural numbers from 1 to 7,825. There will be 2 to the power of 7,825 groups that they need to check. Of course, they could reduce that number of groups down to a bit less than a trillion. And yes, the proof was a huge success to them, literally, because the proof was 200 terabytes big. Yes, a massive, massive proof that would take billions of years to check because of its size. Luckily, the file could be compressed down to about 68 gigabytes for distribution purposes. And while this proof had been around since May, it was only during the SAT conference in Bordeaux during July 2016 that this proof was presented and approved by other mathematicians. And of course, the $100 prize was also given out. Now, back in 1998, Steve Smale set out a list of 18 math problems, and his 7th problem asked how you could rearrange some number of points on a sphere so that they are as far away from each other as possible. Now, a certain variation of this problem is called the Thomson's problem, and rather than dealing with just any points, they deal with charged particles. And the question for Thomson's problem was how you could rearrange these charged particles on a sphere so that they would exert the least amount of electrostatic force with each other. The original poster for this problem was a guy called J.J. Thomson. He intended to use a solution for this problem to describe how the electrons rearrange themselves around an atom in a plum pudding model, which of course we now know is a false model of the atom. Despite of this, scientists still find a lot of uses for the solution to this problem, including how electrons rearrange themselves in their orbitals, or how proteins will rearrange themselves on a spherical virus, or how you could rearrange satellites around the Earth, or how you could place houses of a group of people who really loathe each other, and the uses are just endless. Now, of course, for some cases this is solved. For example, when there's two particles, you could put the particles at the poles of the sphere. When there's three particles, you can put it in the shape of an equilateral triangle. When there's four, you can put a shape of a tetrahedral, and and a few other number of particles they've solved for. Now, a team of scientists, mathematicians and engineers from the United States, the UK and Australia found a new method to approach Thomson's problem that might help them to determine these other configurations for other number of particles. And what they did was they took 7 different number of charges and constructed disconnectivity graphs out of them, and then they used this graph to realize some sort of pattern in the lowest energy states for these different number of particles. And the group of scientists and mathematicians and engineers thought that this method gives them more clue into finding the answer to Thomson's problem, and they've planned on expanding on this method. They're planning on using more number of particles, on using a larger number of charges in their sample, and then see what type of structure their disconnectivity graphs give out, and hopefully move a step closer to solving Thomson's problem. So now let's step out from all these math problems and look at a recent study which have found that women tend to be discouraged to take a degree in the STEM field due to their lack of confidence in Calculus 1 classes. A recent paper co-authored by Jess Ellis, Bailey Fostich at Colorado State University and Chris Rasmussen at San Diego University found that, compared to men, over 1.5 times more women leaves from a degree in science, technology, engineering or math after taking Calculus 1 classes. Now, the main reason for this is not because they can't do it, but more because they don't believe that they can do it. The study involved asking students around the United States about pursuing a STEM degree and other various background questions before and after they take Calculus 1 classes. And they looked at the students who decided not to take further Calculus 2 classes after Calculus 1, and they considered those students to not have an interest in pursuing a STEM degree. Now, some of the reasons for these students to not take further calculus classes are quite obvious. Some of them says that they don't need it for their majors, or some of them says that they already have enough classes in their hands. However, one particular reason strikes out. One reason why many students left a STEM degree after their Calculus 1 classes because they felt that they don't understand the concepts taught in Calculus 1 classes well enough to continue on to Calculus 2 classes. And over 35% of female students who left STEM classes after Calculus 1 shows this as a reason that they haven't understand the contents taught in Calculus 1 well enough, which is a much higher number than the 14% for males. Now, interestingly, out of the female students who left their STEM degrees after taking calculus classes, while 35% of these students don't believe they have the ability, don't have the understanding in their calculus classes to continue, less than 20% of them actually admits that they don't have the grades to actually progress on to do any further. And so basically, the reason that these female students are leaving STEM degrees after taking calculus classes is not because they don't have the ability to do calculus, but they think that they don't have the ability to do calculus. And the main reason for this number being higher amongst female than in male could be because despite of the same losses of confidence level during the calculus classes, women came into these classes with lower confidence levels already, and so with a lower confidence level, with some amount of drop, would make them feel like they can't do any further in their math classes. And this study really shows that calculus classes could be improved in a few different ways. They could, one, try to relate these calculus classes to the specific field that the students are studying, maybe in biology or in chemistry. And two, they can also try to make these calculus classes more encouraging and more supportive for the students who are studying. And currently, only about a quarter of graduates entering careers in STEM fields are women, but hopefully in the future, this percentage will be higher. Well, but that's it for this month's episode of Math News. I hope you enjoyed it. If you have any improvements or suggestions, make sure to leave them in the comments down below. Thank you very much for watching, and I'll see you again next month. But until then, goodbye.